Next we'll look at the integral test. So the integral test says that if our function f is continuous, positive, and decreasing for x greater than or equal to 1, then the integral from 1 to infinity of f of x and my sum of the terms a sub k, which is equal to f of k, either both converge or both diverge. If it does converge, the value of the integral is not in general equal to the value of the series, but it will say that they either both converge or diverge. So for example, here, I'm going to look at the integral from 1 to infinity of k over k squared plus 1 dk. And here I'm going to do a substitution. I'm going to let u be equal to k squared plus 1. So now du is 2k dk. I can divide and get 1/2 du equal to k dk. So when I come back to my integral, this k dk part becomes 1/2 du. And then the denominator is 1 over u. When I stick in 1, k squared, so 1 squared plus 1 is 2, and infinity squared plus 1 is still infinity. So this integral looks like 1/2 ln of the absolute value of u, going between 2 and infinity. And we can see that 1/2 of the natural log of infinity minus 1/2 ln of 2, well, as our values get bigger and bigger and bigger, natural log also gets bigger and bigger and bigger. So infinity. So this will diverge, since my integral diverges. Next, let's look at this one. Here, since my series starts at 3, my integral will start at 3. And I'll go 1 over the square root of 2k minus 5 dk. And once again, we'll do a substitution. I'm going to let u be equal to 2k minus 5. So the du is 2 dk, which can be rewritten 1/2 du equal to dk. So the top now becomes 1/2 du. My denominator is now just 1 over the square root of u, so u to the negative 1/2. If k is 3, then 6 minus 5 is 1, and infinity minus 5 is still infinity. So we'll add 1 to the exponent to get 1/2, and then dividing by 1/2 means we're going to multiply by 2 between 1 and infinity. So this is just the square root of u going between 1 and infinity. So a square root of a really big number minus the square root of 1 is still a really big number. So since the integral diverges, this will also diverge. Do one more. This time, since my series starts at 0, my integral will start at 0. 1 over k squared plus 4 dk. And this integral is actually, we have a form for it, 1/2 tangent inverse of k over 2. We're going to go between 0 and infinity. So this is 1/2 inverse tangent of a really big number divided by 2 minus 1/2 inverse tangent of 0 over 2. So the inverse tangent of a really big number is approaching pi over 2. Since the limit of tangent to the negative 1 of inverse tangent of x as x goes to infinity is pi over 2. Tangent of 0, or tangent inverse of 0, is 0. So this is just minus 1/2 times 0. So I get pi over 4. Since my integral converges, I can determine that this series converges. I cannot necessarily say that this series also converges to pi over 4 just because the integral does. However, I can say that it does converge.